Damit komme ich zum nächsten Vortrag und freue mich, Ihnen heute einen Gast vorzustellen, der etwas weiter anreisen musste, Professor Pawel Wargocki, den ich seit sehr vielen Jahren kenne. Ich glaube, es sind fast 20 Jahre, dass wir uns immer wieder in ganz unterschiedlichen Konstellationen begegnet sind. Und das hat immer Spaß gemacht und es war immer eine kritische Auseinandersetzung mit den Themen. Und ich kann sagen, Pawel Wargocki ist einer der Wissenschaftler, der international wie kaum ein anderer intensiv an dem Thema gearbeitet hat, was ist gut in Räumen für Menschen. Aus ganz unterschiedlichen Perspektiven, hat extrem viel publiziert zu dem Thema, weit über 300 Publikationen, die er in seinem bisherigen Leben dazu gemacht hat. Und ich bin mir sicher, es werden mindestens noch mal so viele werden, ne, weil er ist weiter, sage ich mal, dort an der Speerspitze der Forschung unterwegs. Und ich freue mich, dass wir ihn heute hierher bekommen haben und dass er uns seinen Blick auf die Dinge mitteilen wird. Pawel, the floor is yours. I'm very happy to have you here and I look forward to your presentation.
Thank you very much. First of all, I would like to apologize. I cannot speak German. I understand German a little bit, but I wouldn't be able to present in German here. So my presentation will be in English, but I'll try to make it not academic so you can follow it and try to get some messages home. And then I would like to thank Heinz Trock's Stiftung for an invitation. And I will be trying to say few words today about schools and what is the most important for schools, how can we create an environment for schools that promotes the conditions that give opportunity for children to properly learn and also teachers to work properly. There have been some problems. Oh, yes. So I will start with the obvious facts. I don't think I need to read them, but carefully we have to few points are very important. It is obvious that good education system constitutes fundamentals of the society, and they have lifelong consequences, not only for the economic, for the country, but also for the people, for the society, and people that are students. An early childhood experience impact behavior later in the life. Buildings must promote health, so if we design buildings, we have to think about how the conditions will be healthy for those who are using them. And the primary purpose of school building is to create optimal conditions for learning. And then indoor environmental quality in many schools worldwide is inadequate, unfortunately, and poor indoor environmental quality in schools is linked not only to health problems, but also to decreased concentration and poor test results. And all children and teachers, independent of the socioeconomic status, have the right to breathe healthy air. And also, we can document that this is true, that the proper learning has consequences for the life and socioeconomic prosperity. And this is the OECD study, so-called famous PISA study, I don't know whether it's still continued, which tried to look at the learning of children and their consequences in the subsequent life. And they found out that in survey that adult skills find the foundation skills in the mathematics have a major impact on individual life chances. Poor mathematics skills severely limit people's access to better paying job. And then also, again, something about mathematics is very important, that people with those skills are likely to volunteer more. So there is a connection between learning and how we perform in adult life. So my objective today is to answer 3 questions. I'll see how much I can do. 3 questions, but I'll try to do this because of the time. First is what is the optimal indoor environment for learning? How to examine that learning environment is optimal, and then how to advance research on this. So let's start with the first one and the most fundamental here. Question is, what is the optimal learning environment? This question we asked ourselves before pandemic, and then through the donation from the private foundation in Denmark, we were able to create the report that I will be able to send to you if you are interested in on research-based recommendation for achieving high indoor environmental quality in classrooms to promote learning. In that report, we were interested on all aspects, and I will focus today on thermal environment, air quality, visual environment, and acoustics, and I will tell you what should be the conditions that promote learning. However, also there is other aspects such as the education and behavior and so on, and these are not included, but they should be also considered. So for the thermal environment in classrooms, raised classrooms temperatures have progressively negative effects on children. We should avoid overheating of classrooms. We know that this is the problem that will appear and will be permanent in the future because also of the climate change. And the studies show that basically reducing temperatures by 10 degrees can, or increasing the temperatures by 10 degrees can reduce learning by 20%. Those effects are twice as high for schoolwork than for office work. And then optimum temperature for schoolwork is about 2 to 3 degrees lower than for adults. And in Denmark, the optimum temperatures are about 23 degrees. This is the study that summarized this research. This is my paper, and this shows the relationship between the temperature on the x-axis and the learning. However it is defined, I will not discuss it here, as a relative performance of children in percent. And as you can see, reducing temperatures or increasing temperatures will progressively reduce learning of children. And that is being shown over and over again. You may then ask, what is happening below 21, 20 degrees? We don't have information there. So whether the curve will continue to 16, I would not expect. The curve will probably bend, and then we will see that the optimum temperature is around maybe 20, 21, or 22 degrees. So this is my study, but there is a study in the United States, much bigger study, that looked at the end results of exit tests. It's a matriculation test like in Germany, and then they looked at what is the relation between the outdoor temperatures and the exit exams of students. And they found out across the entire United States that the higher temperature will progressively reduce the results from the exit exams, which is below zero here. You'll see maybe the point at which this will happening is at about 21 to 27 degrees. This is the area where it starts, and then progressively above 27 outside temperature will reduce progressively these exit exams. But of course, question would be, are we talking about the temperature or a thermal discomfort? Because generally, thermal, or our interaction with thermal environment is defined by the thermal discomfort. We feel comfortable and we feel discomfortable. And for the adults, we know that for the office work, the optimal thermal conditions for work are slightly below neutrality. Neutrality is when we are in a balance between our body, exchange of the heat between our body and the ambient environment. And that will be quite expected, because if we work, we produce some energy, and this energy has to be released, and then slightly cool environment will promote learning. We don't know whether this is true and what would be the optimal temperatures for children, because we don't have data on the thermal discomfort and temperatures for children at the age below 18 degrees. There is not even in Funger's book from 70s this information. There is also new research required for thermal environment. These are a few points that are highlighted, and important is whether the teachers are affected, because the teachers also will be influenced by the environment. We know that for adults, that will be the effect that are working in offices, so probably for the teachers as well. And also the mechanisms. We need to understand mechanism by which. Is it by satisfaction or is it by some physiological reactions? So something that we really need to study in the future. Next point is air quality. So poor classroom air quality has progressively negative effects on children. We have heard just before me the talk about the ventilation. I'll come back to this because this is an important point. Here we expect the effects of around 12, 10, 15%. If we increase ventilation and the subsequently CO2 level or carbon dioxide level will decrease below 900 ppm. And those effects will appear for the normal tasks, for the examinations, and also for the absence rate. We see also effects on the absence rate, and these effects are in the neighborhood of a few percent. But they are consistent and systematic. This is just an example of the paper that you can read afterwards and is accessible, which shows the relationships between the learning and the level here of carbon dioxide in the classroom. I will come back to carbon dioxide in a moment, and it clearly shows that there is tendency to improve learning when the air quality is improved. Air quality is improved when CO2 level is increased. About the CO2, there is a debate about the CO2. There is outdoor debate and indoor debate of CO2. And the indoor debate is about, is the CO2 the pollutant or is only a marker? And I would like to quote here Pettenkofer, who said the corruption of the air is not caused solely by the carbon dioxide content. We simply use this as a benchmark from which we can also estimate a higher or lower content of other pollutants, substances. So CO2 has not been documented systematically to cause negative effects. This is the example on the other part of the slide, where you see this is summarizing the effects of pure CO2 and carbon dioxide together with bioeffluents. Carbon dioxide will never appear alone in buildings. We are the main sources of carbon dioxide, so we also pollute the air with all other pollutants together with the CO2, and there are non-systematic effects of pure carbon dioxide. We basically see from time to time for highly demanding tasks, there would be effects of around 1000 ppm and no adverse effects for the normal cognitive performance up to 20,000 ppm. Whereas if we look at the CO2 as a marker with bioeffluents, we already see the effects of around 1000 and below 1000 ppm. I'll skip this slide because this is just summarizing the other effects that we see. These are the effects on the national tests on the left hand, and on the right hand, this is on absence rate. So we see that clearly that there are effects. So now carbon dioxide and gaseous pollutants. You may ask, are there any other pollutants that may cause negative effects on children? And this is the just published study in Environment International this summer that shows that the PM 2.5 is also causing the negative effects on children. It is influencing the absence rates in classrooms. This is a large study from the United States, where they looked at several hundred schools and classrooms over the period of 4 years, and then they monitored PM and ventilation in classrooms, and they found out the relation between the PM levels and the absence rate. So it's not only CO2. CO2 is a marker. It's not only ventilation, there are also other pollutants that we need to deal with. And of course, these relationships, and what I'm saying is not taking into account the risk of infectious diseases. So for the infectious diseases, there are other recommendations, and the recommendations that are out there today are the one that you see here, and basically US CDC is recommending 5 air changes per hour. That is dilution for removing the aerosols. So the 5 air changes per hour should be considered as the base ventilation requirement plus however we remove or kill the virus above the base requirement. And also the new standard that was published by ASHRA this June also defines what should be the ventilation or dilution in the classrooms or educational facilities to deal with the, to reduce the risk of infectious diseases. And this is about 5 to 6 air changes per hour if you calculate and take typical classroom size. For the air quality, we need a new research also. More or less the same is the effects on teachers, interactions with other factors. For example, air quality interacts with thermal environment. So the question is how it interacts. And again, we need to understand the mechanisms. Now 2 other aspects, and one will be discussed after the lunch break. This is a classroom noise and acoustic treatment. So classroom noise has progressively negative effects on speech intelligibility, which means how we understand when we talk. And when the teacher talks to children, how they understand, whether they can understand. So classroom noise has negative effects on speech intelligibility, comprehension, and memory. But there is little evidence that it affects non-verbal tasks. So it has an effect on verbal tasks. Younger children are more affected than older. Children with hearing and attentional difficulties. Children with ADHD will be very much affected. Bilingual children will be very much affected by this. And of course, longer reverberation times should be avoided. Just 2 examples of that. On left hand, we have a background room level for noise, and then we have the native talkers and non-native talkers, and you will see that speech comprehension will progressively reduce much more for the non-native speakers when the noise is increased, and the same we will see with the reverberation time. The longer reverberation time will actually progressively reduce the speech comprehension. And then what about background levels? These are very important. This is a very important topic, especially if we have a technical systems in the classroom. And maybe noise that is penetrating from outside because we open the window to provide airing of the space. So this is the study, again, from the study in the United States that I was mentioning. They were also looking at the effects of noise. And they found out that background noise, so when this is quiet in the classroom, should be kept below 40 dBA. And basically, this is the only significant effect that they have seen of the acoustic environment on learning performance of children. So basically, this meets more or less the requirements of the standard, which says 35 dBA. This is in the quiet period. There are several unknown questions to be answered here. It is how noise interacts with other parameters, also about the mechanisms that are explaining the effects that we see, and how the noise can be best mitigated. One important topic that is discussed is the soundscape, and whether we can actually, whether the different types of noise or sounds actually can affect perception and also performance of children in schools. And this is a study that was just recently published that actually looked at the effects of these different soundscapes, and fan noise was apparently showed a negative effect on performance of children or learning. Finally, daylight. Daylight and green view out and good artificial lighting can improve children's performance, and this is basically the most important to remember is there has to be sufficient daylight. It's an issue because also there is a heat load from the sun and other problems like glare. Then should be green view out if possible, bright artificial lighting that can be regulated between around 300 to 1000 lux, and if very dim light will only affect reading speed. This is what we know. I'm not an expert of daylight. There has been a big study in Europe called Symphony, looking at the conditions in classrooms, made about 7-8 years ago, and they are just now trying to prepare some publications. So there will be more publications coming, and they actually found that learning of children is affected by glazing and the window-floor area ratio, which basically confirms that, daylight is very important and view out is a very important parameter, indirectly, actually. So there's a lot of things that is unknown about the visual environment, and then particularly, again, interactions, mechanisms behind the effects and the effects on teachers. We know very little on the effects on teachers in schools. We know much more on the effects of children. This is a summary. So if you want to go and create indoor environment in classroom, follow those suggestions. Thermal environment 21-23 with operable windows, carbon dioxide levels below 900 with sensors for CO2. Sensors should tell us when to open and close windows because of the energy. Acoustic low background noise, short reverberation times, and day-lit classrooms with green view out and adjustable light levels. Okay, so this is solved. So we know how to do it, and then how can we examine that learning environment is optimal now? So okay, we know from the research that we can do it. We know more or less what should be done. How can we examine that? Well, in order to examine this, best is to monitor learning performance. And these are the methods for measuring learning performance. The academic achievements, cognitive skills, academic behavior, engagement and motivation, mood, and also well-being and health. This is very difficult to measure, and it's not engineering measure. So if we think about engineering measure, we would say, okay, well, let's go and measure parameters. But which parameters we should measure? This is the parameters that are normally measured in indoor environments for different components of indoor environmental quality. About 90 different indicators of indoor environmental quality. Which one to select? Which is the best? Which combination is the best? And which one should be used for that particular task of measuring environmental quality in schools? The problem is, and this is not only the problem of schools, this is a problem of the entire field, is that we don't have a method for rating indoor environmental quality that we agreed on. Well, other disciplines and other fields, they do have it. If we go to the supermarket, we can read what is contained in the food. We have an energy label. We have even for the ambient environment, we have the air quality levels for the ambient air. But we don't have a label or rating for indoor environmental quality. There have been some attempts. I want to show you one of the attempts that we proposed. It's called TAIL. It contains 4 components of indoor environmental quality: thermal, acoustic, I, indoor air quality, L, light, visual. And also that will rate the environment based on the quality of those components. So you'll see different colors, you will see different numbers, and then everything is shown in one rating. This rating will tell you, for example, that the T, which is thermal environment, is good, and I, which is indoor air quality, is poor, and the overall indoor environmental quality is poor because one of the components is poor, which is 4 and red. So that has been proposed for offices and hotels, and now we are working on a new version or the revised version for schools. Basically, these are the parameters that define indoor environmental quality. For the thermal environment, we have temperature. For light environment, we have daylight and illuminance. For acoustic environment, we have noise level. And for schools, we should add reverberation time. And indoor air quality is difficult to define. So there are several parameters that are included. And also include for schools nitrogen dioxide, which has been shown to be a very important pollutant causing problems for children, respiratory problems for children. So for all those parameters, we have defined the levels for different levels of the quality. So we can actually refer to the tables and the parameters. So what is the advantage of this? Advantage is of this that we can build the database with the information. We can compare building between different buildings, and we have the same methodology, the same meter that can be used. This is just an example of this used for the measurements that have been done in schools in France. These are 380 schools, around 600 classrooms. And you can see with a tail, we can clearly show the quality of thermal environment in different locations of school, air quality, and this is just an example for the overall environmental quality. It is not important to discuss here whether this is poor or not. This is a very good illustration on what can be obtained by having that rating scheme. So this rating scheme will tell us useful data for and incentives for improvement of indoor environmental quality. It is a benchmark reference and is a monitoring performance, and it demonstrates invisible. Very often we don't know what's the environment in the classrooms or in the schools, in the buildings is, so TEL will provide this information. I know that I have to finish, so very quickly for the last question is how to advance research and implement present findings. So here, I think I'll go to here. This is what we suggest for the future research needs with regards to the school environment, is to look at the interaction effects, because we are never exposed to only one parameter. We have several parameters that interact on us. Understand the mechanisms, because they can be counteractive. We have to understand the effects on teachers. We need to further develop the process of using the metric for indoor environmental quality in classrooms. We have to think about how to reduce the cross-infection. So this is an issue that has been discussed already before pandemic. We need to understand what are the effects of sleep quality of children on the subsequent learning, and then we have to find the energy efficient solutions. So my time is up, so I'll stop here. Thank you very much, Dirk, for invitation.
Pawel, thank you very much for your presentation, and I think it was very interesting to learn again. It's very difficult to extract good data on field studies. It's also many things and many relations are still unknown and have to be researched. On the other hand, we have to have very simple rating systems in order to point out that even some very basic things that are known for years have to be implemented, otherwise we will have no progress. It's the best way to implement it, to measure, to show red dots, and then at least we all know we have to do something in order to make progress. Thank you very much for your contribution here in Aachen.
Thank you. Thank you again. I just want to add one thing. Maybe you can feel that, oh, maybe we don't know everything. I think we know the basics. We can go now and then design the buildings according to the information that we have. Maybe this is insufficient, but it has there is enough information to do it. Maybe we can further improve it, but we have to start it. Also, for the tail, it is very crude. So some of you may say, okay, it's too crude and maybe it should be more parameters. But we need to start at a certain point, and we need to make this compromise to say, okay, this is how we go, either with tail or another rating, and this is how we can improve further. Rather than debating that maybe we need more research, maybe this is more important or less important, and so on and so on. Schools are the most important building, and has been shown during pandemic that they can actually completely put upside down the entire society, because nothing can be done if children are not in schools. So I think it's important that for our children, for our future, that we do something about the school buildings, and I think the information is there. It needs to be taken and then just applied in practice. Thank you once again.
Thank you.